Hello everyone, it's November the 6th. Alright, I have to do yesterday. Orderly queue. Orderly queue. 66% acceptance. Alright, take a look. You're given a string S and an integer K. You can choose one of the first K letters of S and appended it at the end of the string. One of the first K letters. Return the lexicographically smallest string you could have after applying the mention step any number of moves. So you can do as many as you can. So we move. Wait, hold on. Any one of the first K. Oh, the first K letters. I see. So this one, I can only move the first one. We move the first one. Okay. So this I can move. I move B. And then I move C. I see. Okay. We got it. The general idea. So now I just need to figure out how to do it. So we have a bunch of letters, right? So I don't know. A bunch of letters. And then we're gonna move any number of times. So I can just keep moving, but there will be an end. What is the end? The end is after you finish all the move, you want to do a new move, then it will not produce a better result, right? Because when you move something to the end, another thing will come to the front, right? No matter which one you move, then the next, like you have a K, then K plus 1 becomes the new K, right? So you start moving. Okay, I move this, right? I got a new one, and I decide which one I gotta move. So eventually, I mean, can we just keep moving the large ones to the end? Is that how it's gonna work? I mean, if you have, right, a certain amount, and then you want to make it small, then not necessarily. It's if the move, well, if you think about greedy, right, that means every time you move, then the best one will come. Nah, it's not necessarily. Because you can keep move, you can get something to come to the front, right? Let's say you have, because you have to move one at each time. So in this case, right, BAACA, and let's say if we want to move this A to the front, how do we do it? Well, you have to move, we have to keep the whole thing shift left, and then every time you shift left, you want to only sacrifice the largest one. So you can sacrifice the largest one and it will shift left. You sacrifice the largest one, you will shift left. So as long as you have something that's larger than A to sacrifice, then it's always going to be worth it. Don't you think? Right? Whatever is in the current setup. Yeah, and if you think about it, you can move one of the K, right? And at the end of the day, the end game is the first K all becomes the smallest, right? If the first K are all smallest, then any further move will only worsen it. So the goal first is to get the first K letters to be all smallest. So you can look in the current one, you can find the smallest one already. If it's already in the first K, you just never move it, right? And then you move the other ones, right? You keep moving because they keep shifting, right? They keep shifting to the front, keep shifting to the front. So you keep moving the one that's larger. So you still have you have a k that's the biggest, a k that's smallest, and the remainder that's bigger, right? If there's a remainder in the front, you can always move that to the end. So you shift the rest up. So every time you have something bigger, you move to the end. You have something bigger, you move to the end. So after the move, how many moves? Well, I mean, basically depending on how many in the first k is already the smallest. So you just move all the bigger ones to the end. Now you have k smallest in the front. Now the question is, how do we rearrange them? Yeah, so it's easy to get the k smallest to the front. But then among the smallest, you want the small one to go to the front. So in that case, what we can say is, in that case, I mean, we don't have to think about k, right? So you're looking at your strain, and you have a smallest value, and I say I just keep moving so that the smallest value will go to the front. So you keep moving the front, all right? Once the smallest is there, then you look for the second smallest, and then you keep moving the second smallest. So you get a second smallest at the front. And then, so you can get the first k sorted from small to large. Okay, that is not difficult. You just keep going. Yeah, just keep going. You can say you can do any number of times. So I want the smallest to go to the front. That will be done, right? And because we'll keep going to the front, we'll go to the end. Front will go to the end. Front will go to the end. So eventually what will happen is, wherever the smallest value is, the smallest value will go to the front, and then everybody else just follow the original order, and then you want the second smallest to go to the front. Okay, and you want to, okay, so that's that. But then what? Is that guaranteed to be the smallest? That's a good question. I don't know if that's guaranteed to be the smallest. What if we have CAA, BA, all right? I say I want to make A to go to the front. So I can, yeah, it doesn't matter which A. Which one we want to move to the front? So we move this to the end, right? Then we move this to the end. Okay, that's AACB. Can we make it into BC? This is already the smallest. Okay, let's try, I don't know, I can if I move this one to the end, right? Then I can move this to the end. Yeah, that's, it's tricky because if you see BAACA, right, and 3, and CAABA and 3, both return same results. So it matters. So we know that the smallest can definitely go to the front, but the difficulty is to decide how, right? Both return the same value. So how do we order them such that not only the smallest go to the front, but the big ones, when they go to the end, they also ordered? If you think about it, I have all those, if I can find a rule, right? Or if we can prove that it's always going to be optimal. I mean, if we want to, cheat. Do we want to cheat on this? Hold on. I forgot to do this. That's actually 4, I think. No, I actually don't know. Yeah, that is 4. Yep, I gotta solve this fast, man. Yeah, I mean we can try. Like I don't know, I can just and just kind of take a look. Yeah, I think it's just sort. We can just sort. So I don't think it's difficult to get it right, but it is difficult to prove. So we can prove, right? We can prove that we can get the smallest at the front. But how about the rest? How about the rest? Wait, hold on. Hold on. Hold on. How about this? That cannot work. We only have one choice. No, it does not work. If it's one choice, it does not work. Interesting. I think it's more complicated than that. Yes, we can get the smallest at the front, but the remainder requires work. Maybe that's the wrong way of thinking about it. Maybe we should DP it. Look at it when 1000 in length, right? How do we DP it? Give me a good example. Let's try this so it's not too long, and let's give it 2. Okay, let's give this a 3. See if we can draw some inspiration from this. All right, so let's use this one. GF, no, not GF. Yeah, GFGD, right? NHTTD, and then we have a 2. So what do we say? We say we want to find out, right? So what we want to find out is from the start to the end, and we allow to do this kind of move within the first 2. We want to find the smallest that we can do. So we will know in the final event the G will end up somewhere, right? G will end up somewhere. We don't know where it ends up. So the G will end up somewhere in it. And then when the G ends up somewhere, so which means G must be moved, right? And it should only be moved once. I'm not certain about that. Something at the front. If we pick it. Yeah, so the ultimate goal, yes, is to move the smallest to the front. So yeah, the smallest is D, right? I have two D's. And if we just move them according to current order, that is not going to work. So let's see how the current answer works. Like, how would I move? I have GFG, and you see the end, FGG, right? So I need to move the small to the back first. If I move the small to the back, and I can move the bigger, right? So I move small to the back, so it will be, yeah, let's just move. Let's see how I go. We have two to move, right? So we have the first two, so if I move F, so it'll be G, G, D, and H, T, T, D. Now we can move F to the back. And then, because the goal is to move D to the front. So no matter which one we move, right? So we have moved G, right? Now D is in the front. And we want to move, because there's another D come to front, so we want to move another G, okay? So now it's D, N, H, T, T. So D is the front, so we never move D. So we have to move. Oh, did we never move D? Then it will be D, N, and H, right? D, N, and H. If we never move D, that becomes a 1. So it will be F, G, G, N, H, T, T. N, H, T, T. That is not right. Right? That's not right. Which means once they're brought to the front, that's not the end of the story. We have to keep going. Okay. So we have to keep going. So DN, right? So which one to move? So what is the goal? So if we want to, we move the smaller to the, no, we move the smaller to the back first. So we move D to the back. Okay. Now it's NH, so we move H to the back. Right? And then it's NT, we'll move T to the back. And then TT, both move to the back. Now we have D, F, G, G, D, H, N, T, T. That's almost. Then we just need to move D to the front. F, G, G, F, G, G, N, H, N, T, T. That is interesting. That is actually very interesting. So what you're saying is you always move the smallest that you have to the back. Smallest you have to the back. So you do one round to get the smallest to the back. Right? Until you get to the yeah, because if DF will be D go to the back. Right? It will be F and it will be F. So we D go to the back and F, G, G, D, and yeah, then you will repeat yourself. So once that's done, then you secure one and you do the remaining. Yeah, when it's just one, there's actually nothing. But if it's two or more, and every time you send the smallest to the back, right? And every time you send the smallest to the back, among the ones we have, you send the smallest to the back, smallest to the back, smallest to the back. And then when you send all the smallest to the back, and then the first one you send to the back become the first one. No. When you send all the smallest to the back, if you go do it again, then you will repeat. Hold on. You have this amount, right? You send the smallest to the back, right? And then you got a new one. You send the smallest to the back. So they might not be sorted, right? So you wait till them to go to the front again. Then you do it again. You wait for them to go to the front again. So every time when you send them to the back, you sort it a little bit better, right? You sort it a little bit better. So initially you have a large window, and then you get a smallest to go to the back, smallest to go to the back, right? And it's not finally sorted, but you get each time when it goes to the back is the smallest among the current pack, right? And then eventually, when they're all cleared, right, you want to go to the front. Yeah, you know how many times to run, right? That's one round. And after one round, you're going to ask yourself, okay, now we need to get a little bit more stringent, right? So what does it mean by getting more stringent? It means you want to secure the smallest place. So what you're going to do is you will keep running at least for the first round, right? For the first round, because you want to use, because the sort capability is just your window, right? So you want to go through the first round where everyone has at least a chance to be sorted, and then you wait for the smallest to go to the front. And when the smallest go to the front, because once you sort it for the first round, I'm pretty sure if you keep going, you will repeat the same pattern, right? You will repeat the exact same pattern. So now you need to make it more difficult, more stringent. So you get the smallest to reach the front and secure its place. Now the string gets smaller, your space gets smaller, and from there you select the smallest. I want to test this theory. I mean, I just came up this, out of nothing. I didn't really think about too much. All right, I'm not looking at the answer. I'm gonna follow this rule. So what I have, the first one is REWTRGFSW. I will first sort this so I know who is the smallest. Right? I want to know who is the smallest. So if I want to go small to large, it's going to be E, right? E is the smallest, and then EFG, right? EFG. Then we have RRSTW, right? That's completely sorted. And we have two positions. So let's see. So RE, we throw E to the end. RW, we throw W on R to the end. WT, T to the end. WR, R to the end. WG, G to the end. And WFF to the end. WSS to the end, and WW, well, both gonna be go to the end because we want to go back to the front, right? So W to the end, and then W to the end. So after one round, we get ER TRGFSWW, right? And then we're trying to see, okay, so the second round, no, before the second round goes, right, we need to keep moving until the smallest is the front. So smallest is E, and E happened to be in the front. So this position is secured. So from the second position, we're just gonna keep rolling until the second smallest go to the front. Second smallest F. So we just keep moving until F is the front. So it will be E, F, right? So R go to the end. E, F, S, W, W. R, T, R, G. No, that's not right. That's not right. You can get a W to the end. How do we get a W to the end? After the first round. Nah, this theory is not working. Doesn't work. It's actually, they get to the smallest. This is the smallest. Wow, actually I don't even know how the smallest gets done. Let me think again. How about we run it again? We have E, R, T, R, G, F, S stuff. This is the first round. Second round, let's run this exact thing again, okay? So we have E, R, T, R, G, F, S, W, W. If we run it again, E go to the end, R go to the end, T and R, R, S, T, R go to the end, T, G, G go to the end, and F go to the end, and S, T, S go to the end, T go to the end, and then W, W. Okay? So we come E, R, R, G, F. So it's different. Let's run it again. Right? Let's run it again. If we run it again, we have E, R. Okay, if we run it again, E go to the end, R, because R go to the end, R, G will be G go to the end, R, F, F go to the end, R, S, R go to the end, S, T, S go to the end, and then T and W, W. Now it's E, R, G, F, R, S, T, W. It's different. So every time it's different. Let's do it one more time. E go to the end. Okay? G go, because it's RG, so G go to the end. RF, F go to the end. Now it's RR, right? RR go to the end. And then STWW, that's just GFRR, STWW. One more time. E go to the end. GF, F go to the end. Then G go to the end. And then RRSTW is already sorted. I think you just keep doing this. You keep doing this until there's no more change. That's what I think it is. That's what I think. That's why it has such a high passing rate, because the algorithm itself is not difficult at all. But But proof wise, like, can we prove this? This is basically, is this count as a oh, I didn't even save yesterday's. Oh shoot. Let me just save this. Yeah, I didn't buy this. Oh, that's okay. That's okay. Man, how do I prove it? Well, the way you prove it is at the end. We can say at the end, yeah, when it reaches the ultimate state, then if you follow the same pattern, it will never change, right? It will never change because it's already in the optimized way, so it will never change. Which means if it's not in the optimized way, because when we move it, we add a new thing to the front that we can do the change. Like if it's not the optimum, then something will change, right? Then something will change. So the argument is as long as we can make some change, then we can keep improve it, right? Keep improve it. But now the question is, can we optimize this a little bit? I think we can. So after the first run, right, we can compare this to the previous run. And anything that has not changed, anything that's not changed, that means it's, yeah, really? You know what? Let's solve it first. We'll think about optimization next. Well, yeah, there's definitely use a deck. That'd be much easier. So we import a deck. I am not sure, but we can try. We call it Q equals deck. We can try deck S. Maybe it works. What are you doing, man? And then, dude, how do you get a state? Pre-S. I don't know. Wow. While true. Yeah, I'll just go infinite. And then if we're gonna do this, so from the first K, we find a small, oh man. We have to run another thing to find the smallest. This might time out, honestly. This might time out. But if the K is huge, then we might only need to do it once, then we can already sort everything. Like not that many times. Okay. So what do we do? What we do is number of times, right? Number of times. So for this in range, length, that's the number of times. So we can move 1, move 2, yeah, move that many times. So each time we're gonna go to the first K, and then we find this minimum, right? The index of the minimum. So we say index and min character is, I don't know, what's a min character? It's called main value. Doesn't matter, main value. Main value is something big. Okay. And then we say for, oh Jesus, so many for loop. Right? For every position, actually I need position. So for I in this to K, and we say if ord Q I, right? If that is smaller than main value, then index main value equals I and ord Q I. So we run this. Once we run, we will, dude, how do we Oh, we just need to, so we need to pop this. How do we, well, we pop this, we can put it to the end. Wait, hold on, I haven't thought it through. We can't. I mean, we can pop the front. Oh, it's fine, we swap with the front. Then we pop it. Yes, we swap with the front. So we swap with the front. How do we swap with the front? We say Q0 and Q index equals Q index and Q0. So we swap with the front. Then we say, then we say what? We say Q dot append, right? Q dot append, Q dot pop left. So the left popped is the one we chosen and then push it to the end. And then it's fine because the previous K, we don't need to order them. We just need to include new ones. It's every time we select the smallest, right? So we pop to the end. So that's one round. So we keep doing another round until we finish all the rounds. Then we say current s, right? We say it's going to be dot join. Oh, this is going to take time. Q. Right, and we say if current s is, we can actually do this. We can just say current s is empty, right? And then we just say while current s is not equal to previous s. You know what? I don't like it. I don't like it. I can say if current s is equal to previous s, then we're just gonna return, and we're gonna break, right? And then we'll return current s. If it's not, then we say pre-s is equal to current s, and then we keep going. So this is kind of my way of interpret it at the moment. Yeah, we get some easy case. This is ACB. This is an interesting case. This is AABC, right? AABC, and then let's get rid of these. And then we have, I think I figured out another case where I swap C and B, but the results are the same. And of course I have these test cases. Okay. So for this, answer is and for this, all right. Yeah, this is not the best one. I'll have to find the one that I like. This one is not the best one to do this type of work. Order this. Ooh, what the hell? Which one? Something I didn't do? Huh. I can't keep A. Wait, what? What did I do wrong? It didn't make any sense. CBA, right? I can only do K is 1. So it's just the first one, right? So index is going to be 0. So I pop 0, pop left, and then Q over 10. So it will be BAC, and it will be BCA, and then it will be ACB. And I pop A again, it will be CBA. Oh, shoot. Man. Gotta be a little more complicated than that. And then we have C, 2, and 3. Damn. And how many times do we run this? Huh. No, this doesn't work. We end it with CBA. Because that's the first move, that's the second move, and that's the third move. After 3 moves, this is after 3 moves. And you throw A to the back. No. And that's another way. I mean, when A equals 1, you know what, this is edge case. I can solve it. This is infinite. Why would it be infinite? It's never the same? What? What's the previous S and current S? BACA and then CBAA. So CBAA, BCAA. Oh, BCAA, CBAA, BCAA, CBAA. That's the problem. That is the problem. The choice. The choice. How about this one? Nope. Same thing. Just can't settle. But we run this already. Well, we know it does settle. Wait, hold on. This thing, we run it. And it does settle. Let's No, I won't. I want to see. Okay, so we start with, actually I want to start with this WT. So we move T to the end, right? WG, G to the end. WS, S to the end. W W to the end. Oh shoot. Oh, I see the problem. Because I implicitly I move WW to the end. So when they are the same, I move both to the end. When they are the same, you need to move both to the end. Okay, when they are the same. Which just means if they are already sorted, you move the entire thing to the end. Is that the reason? Yeah, because the purpose of moving smaller to the end is you want the bigger ones to land at the end once you finish your round. Hold on. 1, right? 2. If every time we move the smaller, then at the end, it's going to be the biggest, right? If every time we move the smallest to the end, then the ones that's remaining is the biggest one, right? Right? If we keep doing this, then I have to move the last one, and the last one to move is always going to be the biggest one. So we have isolated out the biggest one that can go to the end. And can we just cut it out? Because they're just gonna keep going and then they will go back to the end again. Yeah, then we can shrink it down. So every time we can shrink the size, every time we shrink the size. And what I'm also thinking, yeah, don't also think. We just pop it. Okay, I have a new idea. We don't need this, so we have a Q. Then we have a reverse res, okay? And then we say while len reverse res is smaller than len Q. Okay, then then yes, we do push. Say yeah, when it's 1, I think it's a separate situation. There's no choice. But if it's more than 1, then we have some choice. So 1 is a special case. Okay, 1 is a special case. Okay, so we can write a situation 1. Def solve 1. Solve k equal 1. Okay. Oh. This will be, we push, and eventually we have a bunch that's gonna be 1. Ooh, we have to handle, this is not, so while k is larger than 1, right? And then we solve k as 1, that's going to return str. So what we do is we keep moving, right? Move things back, and we find the smallest, and That's one version. And then we keep going. Find another one. Then we keep going. Then we find the first one. Okay, so potential result. That's called a set, right? And then the Q equals deck S. And then we just keep going. Well, true. Once it start repeats, that's when we stop. Well, true. We just say we find the smallest, right? And then we say min letter is equal to the minimum of S. It works, right? Minimum of S. I don't know. Yeah, it works. So we have the minimum, and then we say, well, true, if, right, if Q0 is equal to minimum letter, then if then current S equal to join Q. If current S is in potential rest, I'm gonna break. Otherwise, potential rest dot add current S, right? If it's in, then we do all these actions, and if it's not in, we just, and if it's in, we'll also push it to the back. Then we just say Q dot append Q dot pop left, right? So once it's in and we break out, so we just return the minimum of potential rest. So that's that. And I say, well, k is larger than 1, right? Well, k is larger than 1, then we just move the things to the end, right? So we're gonna move this number of times. That's correct. So every time we're gonna do this is all fine, and then no, we don't print right now. All right, so every time we just go from front to k, and we say if it's smaller than minimum, we probably have to buy a time trouble, because I think we only have 10 minutes left. Yeah, only have 10 minutes left. Let's see if this idea works, then we shall be able to solve it, right? And then we have the k, the first k, we find the smallest, we shove that to the end, right? And shove that to the end, and eventually what happens is with but how do you identify this? Because we shove the smallest to the end, and if we have the bigger value in the front, right? So after the last one, we should do 1 fewer minus q len q minus 1, right? We do 1 fewer such that we know in the front, the biggest value in the front is going to be the bad one, right? The biggest one in the front is going to be the bad one. So we can just pop that one. Ooh, lordy. So we have to do this one more time. Def find max. Okay. And we have a q. Then we have a range. So we have j. Okay. We're gonna return tuple of int and int. All right. So we say for I in range j. Oh, is j the index, or let's call it k. K is the number, right? Okay. Actually, just copy and paste this entire thing. Okay. So when I find max, so this is going to be negative infinity. And then if this is larger than max, then I'm going to record. Right? And then we're going to return index and the max file. Then we're going to do exactly the same for find min. So all the max going to become min. And this is going to be the positive. This is going to be smaller. So with this, we can say every time we can do index and the min value. I mean, I don't even need min value at this point. Yeah, I don't even need min value. Why you return min value? I just need index. I just need index. So this is not necessary. Yeah, I just need to know which index has the smallest or biggest value. So we say the mean index, okay, equals self find mean q and k, right? So we find this, we swap this, and then we do this, right? And we just keep going. Once we're done, we're gonna say max index equals max index equals self dot find max q and k, right? We find a max, so it's the maximum. So this is guaranteed to be the maximum, right? So for this max, we are going to do the same thing. No, this is not. This is the min index. This is going to be the min index. This is going to be the max index. It's going to be the max index, right? And then we're going to pop it. But we're going to put into the reverse this dot append q dot pop left. Right? So we put that one inside, and then k minus equal 1. We go back, then we churn it again, right? Churn again. Once we finish, once the k is equal to 1, then we say the front, the left s is equal to self dot solve k equal 1. Solve k equal 1 s. What's the s? There's no s. There's only q. We don't need to do this. Okay, there's only q. Right, so this is the left s. Then we're going to return left s plus dot join, reverse this, and then reverse it. Now we run it. Oh, almost. All right, we have to buy it. Yeah, there's only 2 minutes left. I don't think I can finish this in 2 minutes. What is the issue? So we got, we didn't even get a, we get a S. How is it not working? Because we only have 2. Then once we're done, then once we're done, we only have 1. So now what do you say? Yeah, we need to keep the window open to keep it churn, right? Keep it churning. Keep it churning. Don't get rid of it immediately. So how about we don't do this, right? So we get a W out, we get the next one out, we get the next one out, but until when? Until when do we stop? Until, right, exactly. Until when do we stop? Yeah, when now we have a smaller, we can find the maximum among them. We send it, we pop it, right, to here. And then with smaller, we find the maximum, send it, and then we have, keep going until we have 2 values. Then we can find the maximum, send it. Yeah, that's the thing. But I think I had an example where it's not sorted. Like in this case, you're thinking, all you're saying is it's just like sorted. But I think I have a case. I forgot. Some case is not sorted. No, they're all sorted. Like seriously, like in this case, if you think about this way, right? You have your first K, and then you can always get the maximum among this. You send the smallest back, So it's like monotonic, right? So you get a new one in, it's always the smallest go. So once you go through everything, then the largest one in the front is going to be the largest overall. So you send this to the back, and you just don't worry about it. And then for the remaining, you do the exact same thing. Like seriously, I think maybe all of this is not necessary. I think what we do is, dude, seriously, we say if k is equal 1, then we return self.solve k equal 1. And then this one has to be s. Deck s, right? S. Else, then we just return. Oof. Yeah. I have to do this. Join sorted s. That's kind of what I think it is. Like seriously. I think this is the case. Just when it's 1, it's a special case, right? We can actually okay, and then from string import ASCII lowercase. I don't know how many test cases run. 10 test cases. Print. We also need a rand int. And we say, yeah, range 10, right? Then we're gonna print. All right, so we're gonna print. I'm gonna say join. Nah, this is a stupid way of doing this. We can just say s equal to, right? join for this in range 1000. Right, let's be bold, and we say choice ASCII lowercase. Okay, and then we're gonna print s and print randint 1 to 1000, and we just run it. Oh, dude, I cannot select. Are you serious? I can select on the other laptop. Paste mode. No, man, I can. I cannot use the cursor. Complete by typing. I don't know. Maybe, how about we're using this? Dude, I can't even have to exit in order to select. Nah, this is turned out to be quite stupid. No, I think this is probably wrong. No, this is right. Dude, I think this might be right. Seriously. If we go like 1, 2, I don't know, just 3, 4. Okay, try it again. Yeah, I think that's the one. I'm gonna write some comments. Well, let's see, $8.99, right? I think. Okay, think about it this way. If each time we select the smallest value in the first K letters and put it to the end, eventually, after going through all the letters, it is guaranteed that the largest letter among largest letter in S is in the first K letters. We can then put that letter to the end such that we have successfully, right, placed the largest letter in its sorted place. Then we don't have to worry about that sorted letter again, right? Because it is already in place, which means each time we know, right? Which means we know exactly when that letter needs to be popped and pushed to the back in the future rounds. Therefore, we can focus on the remaining letters and find the second largest letter. Eventually, this will lead to a fully sorted string. Now, the only exception is when k equals 1, right? Because in this scenario, it is not possible to do any choices. Thus, k equals 1 has to be treated separately. Okay, this is kind of how I would want to do this. Okay, let's see. I'm very confident in this, very confident in this. Let's hope it's not wrong. All right, go for it. I've done it. I've done it before. No, I have to use the streak. Oh, they probably use it. Wait, hold on, what? Huh? Something is not right. Something is not right. You know what? I think the daylight saving time is messing them up. Does it make any sense? I don't know. But anyway, 106 test cases. Ah, I solve it myself this time. Last time I didn't solve it. But k equals 1, this is much easier. It does seem much easier. Yeah. We'll just keep this one. Right, so this swap. Right, and then oh yeah, it can be made much easier. I done it in a stupid way. Let's do that again. 111. Yeah, just slightly more. That's okay. That's okay. That's not a big a deal. So update. This can be written in a much easier way. Screw all this, right? So we just say for I in range 1 to len s, so res equals s. Res equals the minimum of res and s, because I want this to be the same. So it's this to I, right? So because what happens is go to the end, so these all go to the end. So it's the front to this, so it's gonna be si to the end plus s to the I, and then I'm gonna return s. Oopsie doody, that ain't right. Yeah, so we have 1, right? To 1 is gonna be C. So it's gonna be 1 to the end, so BAC. Okay, and then 2, 0, 1, 2. Maybe 2 to the end, which is A, and then 2, which is ACB. How is that not right? What? Oh, dude, rest. Lord. That's more like it. All right, that's it. I'll see you guys maybe in 20 minutes. And adios.